Okay, so we're going to be, we plotted these points. I plotted these in advance. It says graph each figure in the coordinate plane and then find each perimeter. So what we need to do is we need to find these lengths. As you can see, because from A to B in blue and from A to C in green, we're at a diagonal, we need to use the distance formula. So I'm going to start with A to B, and I'm going to call them, I'm going to say, okay, let's call A point 1, so we have x1 and y1, and let's call B x2, y2, point number 2. Okay, so then I'm going to sub in these numbers, and we're going to say, okay, then you've got x2, which is 4, minus x1, which is negative 4, and all of that squared plus y2, which is 5, plus, minus y1, which is negative 1, and that squared, and what we get is the square root of 4 minus negative 4 is 8, so 8 squared, plus 5 minus negative 1 is 6, so 6 squared, and what we get there is the square root of 64 plus 36. And what that equals is the square root of 100, which normally wouldn't go across, I'd keep working down, but that is 10. So AB is 10, distance formula, okay? And I'm going to erase what's up top and now say we're going from A to C, so now I'm going to label point A, let's say x1, y1, and point C, x2, y2. And I'm going to do the same thing again, where I rewrite this and I put brackets in so that I can substitute in the values. And is this more work than you need to do? Nope, it's exactly as much work as you need to do. So if you're someone who says, oh, but Mr. Massey, it's so much work, it's like, okay, well, it's as much work as it needs to be in order to get it right. So let's sub in the values. x2 is 4, x1 is negative 4, y2 is negative 2, y1 is negative 1, and we get then 4 minus negative 4 is 8, so we've got 8 squared, plus negative 2 minus negative 1 is negative 1 squared. I put that in parentheses because it's a negative that I'm squaring, and so I have to do negative 1 times negative 1. If it didn't have parentheses, I wouldn't get that. So then you get the square root of 64 plus 1, which equals the square root of 65. And that is that's not going to work out to be a nice whole number, so I'm going to leave it like that. And then for B, we've got, notice this, they're going along the same grid lines, and the x-coordinate does not change. We're not going any further to the right for one point or another. So what we're doing is we're going to subtract, just like we're doing the ruler postulate, this y-coordinate minus this y-coordinate, or we can say the absolute value of 5 minus negative 2. We do the absolute value to make sure that we're always getting a positive number because it's a distance, so it's that. And this one is square root of 65. And if I want the exact answer, now I'm just going to sum them up, and I'm going to write it up on top. And I'm going to say 10 plus 7 is 17 plus root 65, which, by the way, this is just a little more than the square root of 64, which is 8. So it's a little, this is 17 plus a little more than 8, so it's going to be a little more than 25. So it'll be approximately 25 point something. Okay, but I'm not actually going to leave that as an answer because we can give it as an exact answer, and that exact answer is like this. Okay? That's how you do it. We're going to do it again for the next slide. All right, so 3 of these 4 sides are directly along the grid lines, which means we can use the ruler postulate for that. So to do, let's say, SV, that's going to be equal to the absolute value of the 2 y coordinates. It's only changing in the y direction, so we say the absolute value of 3 minus negative 6, which is equal to 9. This has a length of 9. Hopefully you can see that. V to u, that purple side, is only changing in the x direction, and so we say the absolute value of negative 5 minus 7, which is negative 12. Absolute value of that is 12. That has a length of 12. And from u to t, in blue, we're going to take the absolute value of, the only thing that's changing is their y coordinates, so you've got negative 2 minus negative 6, which is negative 2 plus 6, which is 4. That's got a length of 4. Hopefully you understand that lengths are always positive. And so now we've got 3 of the 4 lengths straight away, and what we need to find is s to t. And s to t is equal to this right here. And so for s to t up top, you can see that I'm going to label point S as point number 1, so that's the x coordinate of point 1, the y coordinate of point 1, and t is point number 2, so that's the x coordinate of point 2 and the y coordinate of point 2. So when I substitute in here, I get the square root of, now I've got to substitute in the numbers. So since I'm substituting in numbers for variables, I put parentheses anywhere I'm going to sub it in, and if there was already parentheses there, the outside parentheses become brackets. That is a standard convention. And then we sub in those values, and so we could say, okay, what is x2? 7. What is x1? Negative 5. What is y2? Negative 2. Minus y1, 3. And we got 7 minus negative 5 is 12, so we've got 12 squared plus negative 2 minus 3 is negative 5, so it's negative 5 squared. The reason that I'm writing it when there's a negative, I write it in parentheses like this, is because if you had something like this, negative 5 squared, that would say, do the 5 squared first, then make it negative, and that would be equal to negative 25. Versus if you had this, which says the base that you're multiplying together multiple times is negative 5, so that's like negative 5 times negative 5, which is 25. This right here does not say negative 5 times negative 5. I always say exponents are lazy. It's going to work on as little as you tell it to. And so if you tell it only to raise 5 to the second power because you didn't attach this together and say you got to deal with that as a group, then the negative will get left off from the squaring. Okay? So that's why here when I want to square this, I have to put it in parentheses. Okay? Let's keep going. I've got then the square root of 144 plus 25 which is the square root of 169, which is really nice and neatly 13. Sweet. Oops, not square root of 13, sorry. 13. So, these are the 4 measures that we have. We have a side length of 9, side length of 12, a side length of 4, and a side length of 13. And if we were to then say, what is 9 plus 12 plus 4 plus 13, we would get 38. And box my answer to show that that's my final answer. Yep, that's it.